7.10. Show that moment of couple does not depend on the point about which you take the moments. Okay, so here take one rigid body. This is our rigid body. Okay, so on that uh, 2 points of the rigid body we are taking, this is A and B. Okay, so this is A and it is our B. Okay, so the two forces are acting on that rigid body is, one is here like in this direction, this is force F, and another one is opposite to that direction, that's why it is minus F. Okay, so the position vectors of A and B, this is we are taking, this is one arbitrary point O. From that arbitrary point O we are taking the moments. So before that, the position vector for the A is here, this is R1, and position vector for B from the O, that is R2 vector. Okay, so A to B, it is another vector, that is one point of the rigid body, and this is another point of the rigid body. So then let us take the moments of forces about the origin. This is arbitrary point we consider as a origin. From that origin we are taking the moments. Okay, so the moments of the, here it is a one force in this direction and opposite to that direction, means there are two forces acting at different points of the object in opposite direction, means the couple, moment of couple is acting on this object. Okay, so the moment of the couple is equal to the moment of couple equal to sum of the moments of particles at A and at B. Okay, so sum of the moments of these two forces. Okay, that is sum of the moments of two forces. Okay, what are the moments? Moments means here force moments, F into R1 and F into R2. So here according to our torque, this R1F, okay, this is R1 cross vector R1 cross minus F, here force is minus F, plus this is R2 vector cross, this is force F. Okay, this is the force F. Then this is also we can write it is this is positive, so I'm writing first, that is R2 vector cross F vector, this is plus, this is R1 vector plus of minus F vector. Okay, so this minus we can write here also, that is equal to R2 vector cross F minus, that minus I am taking to here, and it is equal to R1 plus F vector. Okay, so then from here and here we have a what, sorry, this is R cross, this is R cross, it is also R cross. Okay, so F and F is taking common, so if F is taking common, this is what, R2 vector minus R1 vector cross F vector. Okay, like our distributive law. Okay, so distributive law in vector subtraction. Okay, so means after this we can write this r2 minus r1. R2 minus R1 is nothing but here. This is the position vector R1 and this is AB vector. Both are in same order and it is in opposite order. This is also position vector. According to the vector triangular law of vector addition, this is vector AB and this is vector R1 and this is vector R2. Okay, so these two are in same order, so that's why r1 vector plus ab vector is equal to r2 vector. From that, ab vector is equal to r2 vector minus r1 vector. So in place of r2 minus r1, now we have to use ab. So that is ab vector cross f1, sorry, f vector. Okay, this is what moment of moment of couple, moment of couple. Now in this moment of couple, there is no there is no origin. It is not depending on origin because we are getting here what AB. Okay, in the formula we don't have a origin, so that's why this moment of couple is not depending on the origin from where we have taken the moments. Okay, from here we are taken the moments, but it is not depending on the world. It is only depending on the distance where the forces are acting and between that forces. Okay, so this is 7.10.